Every year, somewhere between 1,000 and 6,000 shipping containers fall off cargo ships into the ocean. The number varies a lot depending on which study you look at, and the World Shipping Council puts the average at around 1,566 containers per year when you exclude major catastrophic loss events. That might sound like a lot, but considering that the global shipping industry moves roughly 800 million container loads annually, it represents a tiny fraction of total cargo. Still, thousands of containers sitting on the ocean floor or floating just beneath the surface creates real problems that are worth understanding. Modern cargo ships can carry anywhere from a few hundred to over 24,000 20-foot equivalent units, which is the standard measure for container capacity. These containers are stacked on deck in large blocks, sometimes 6 or 7 high, and they extend deep into the ship's hold as well. The ships that carry them are enormous, some of the largest vessels ever built by humans. A modern ultra-large container vessel can be over 400 meters long and carry more than 200,000 tons of cargo. The containers themselves are standardized steel boxes, either 20 or 40 feet long, designed to be stackable and lockable together. On deck, they're secured using a system of twist locks, lashing rods, and turnbuckles. Twist locks connect the corners of stacked containers together, and lashing rods run diagonally from anchor points on the ship's deck up to the containers at various levels. The system is designed to keep everything in place, even in rough weather. When it works correctly, containers stay put through significant wave action and wind. When something goes wrong with that system, or when conditions exceed what the system can handle, containers go overboard. The main causes of container loss break down into a few categories. The most common is severe weather. When a ship encounters a major storm, it can experience extreme rolling motions, tilting side to side as well as pitching fore and aft. In the worst cases, a ship can roll 30 to 40 degrees or more. At those angles, the forces on stacked containers become enormous, and if the lashing systems aren't perfectly maintained or the load isn't distributed correctly, containers can shift, topple, and go into the sea. The containers at the top of a stack are most vulnerable because they experience the greatest movement during rolling. Improper loading is another significant factor. Containers need to be loaded in a specific way to maintain the ship's stability. Weight distribution matters a great deal. Heavier containers should generally go lower in the stack. Misdeclared cargo is a well-documented problem in the industry, where shippers underreport the weight of a container to save on fees or avoid regulatory attention. When a ship's loading plan is based on inaccurate weight data, the ship can end up less stable than the crew expects. This increases the risk of excessive rolling in bad weather and raises the probability of container loss. Structural failures in the lashing equipment can also cause losses even in relatively calm conditions. Twist locks, lashing bars, and turnbuckles are mechanical devices that wear out over time. If maintenance schedules slip, a single failed connection can lead to a cascade where multiple containers shift and fall. There have also been cases where manufacturing defects in lashing equipment contributed to losses. Parametric rolling is a less well-known but important factor. This is a specific type of ship motion where, under certain wave conditions, a vessel can enter a self-reinforcing rolling cycle that rapidly increases in severity. Container ships are particularly susceptible to this because of their hull shape. When parametric rolling occurs, it can develop quickly and reach dangerous angles before the crew can respond effectively. Several major container loss events have been attributed, at least in part, to parametric rolling. When containers go overboard, the immediate situation depends on what's inside them. Steel shipping containers don't float indefinitely. An empty container can float for a while because it traps air, but most containers that fall overboard are loaded with cargo. Depending on the contents, a loaded container might sink immediately, or it might float for days, weeks, or even months if the cargo is buoyant enough to offset the weight of the steel box. Containers carrying items like foam products, plastic goods, or other low-density materials can float for surprisingly long periods. During that time, they're extremely dangerous to other ships, particularly smaller vessels. A container floating just below the surface is very difficult to see, especially at night or in rough conditions. and a collision can cause serious hull damage. Shipping companies are generally required to report container losses to maritime authorities, and the ship's crew will attempt to note the last known position. But actually recovering a lost container is a different matter. The economics almost never make recovery worthwhile. Ocean conditions move containers quickly, and within hours of falling overboard, a floating container could be miles from where it entered the water. Hiring salvage vessels to search for and retrieve individual containers is expensive, and the value of most cargo doesn't justify that cost. Insurance typically covers the cargo loss, which removes the financial incentive to recover it. As a result, the vast majority of lost containers are simply written off. Containers that do sink settle on the sea floor, sometimes in water that's hundreds or thousands of meters deep. In those cases, recovery is essentially impossible. With current technology, the cost would be completely prohibitive. In shallower coastal waters, there have been occasional recoveries, usually when a container poses a direct navigational hazard or has caused visible environmental damage. But these are exceptions. Most containers that reach the seafloor stay there. On the seafloor, a steel container doesn't just disappear. It can take decades to corrode significantly in cold, deep water, and during that time, it becomes part of the local environment. Research has shown that sunken containers can function somewhat like artificial reefs, providing hard surfaces that certain marine organisms will colonize. However, the interior of the container, along with whatever cargo it contained, can leach materials into the surrounding water. Depending on the cargo, this can range from mostly harmless to genuinely problematic. Plastics, chemicals, and other materials can be released into the marine environment over time. Hazardous cargo is a serious concern with container losses. Ships carry all kinds of dangerous materials, batteries, chemicals, fireworks, fertilizers, and more. When these containers go overboard, the cargo can disperse into the water column or wash onto beaches. One well-documented example is the Tokyo Express incident in 1997, when a container ship off the coast of Cornwall lost 62 containers in a storm. Among the lost cargo were nearly 5 million pieces of Lego, many of which have been washing up on Cornish beaches for decades since. That particular cargo was harmless, but it illustrated how persistent and widespread the debris from a single incident can become. More serious was the loss of cargo from the container ship MSC Napoli, which ran aground off the Devon coast in 2007 after storm damage. Containers washed ashore, containing a wide range of goods, and the incident prompted extensive cleanup operations. The ship itself became a wreck site and had to be partially demolished in place. One of the largest container loss events in recent memory involved the container ship One Apus in November 2020. The ship encountered severe weather in the North Pacific and lost 1,816 containers overboard, one of the single largest losses ever recorded. Images from the ship after the incident showed catastrophic damage to the deck cargo, with thousands of tons of containers destroyed or missing. Incidents like this are rare, but demonstrate what can happen when a large vessel encounters exceptional conditions. The environmental impact of container losses extends beyond the immediate cargo. Persistent plastic goods, packaging materials, and industrial products that spread from sunken or broken containers contribute to ocean plastic pollution. Fishing gear, foam packaging, and small manufactured items are particularly problematic because they break down into microplastics over time. Marine animals can ingest these materials or become entangled in them. When a container breaks open on the sea floor, its contents can spread over a wide area depending on currents and water movement. Floating containers also present a collision risk to marine mammals. Whales in particular can be struck by semi-submerged debris without either the animal or ship having much opportunity to avoid it. While it's difficult to attribute specific whale injuries or deaths directly to container collisions, the hazard is considered real by marine researchers. The shipping industry has made efforts to reduce container losses over time. Better weather routing, where ships use meteorological data to plan routes that avoid the worst conditions, has become more sophisticated. Improved lashing standards and more regular equipment inspections have been implemented following high-profile loss events. The World Shipping Council conducts periodic surveys of container losses and uses the data to advocate for better industry practices. Several regulatory changes through the International Maritime Organization have tightened requirements around cargo weight verification. The Verified Gross Mass Regulation, which came into force in 2016, now requires shippers to verify and declare the actual weight of every container before it's loaded onto a ship. Technology is also playing a role. Some containers are now equipped with GPS trackers, which can help locate lost cargo and provide data on how containers drift after going overboard. This information is useful both for search efforts in the short term and for modelling how debris spreads over longer periods. Sensor systems that monitor lashing tension in real time are being developed, which could allow crews to identify failing connections before they lead to a loss. Improved stability monitoring systems give officers better information about the ship's condition in changing sea states. Despite all of this, container losses continue because the fundamental challenges haven't changed. Ships operate in one of the harshest environments on Earth, carrying enormous quantities of cargo across thousands of miles of open ocean, often in regions where severe weather is common. The forces involved in a major storm are genuinely extreme, and no lashing system is infinitely strong. Misdeclared cargo weight remains a persistent problem that's difficult to fully eliminate without physical verification of every container, which isn't practical at the scale the industry operates. The reality of where most lost containers end up is straightforward. The ones that sink quickly settle on the sea floor, often in deep water, and stay there more or less indefinitely. The ones that float eventually take on water, become waterlogged, and sink as well, usually within a few weeks to a few months. A small portion of floating containers wash ashore and are discovered on coastlines around the world. The cargo they carried disperses into the ocean or washes up on beaches, sometimes far from where the original loss occurred. None of this is easily reversible once it happens. Container losses remain a challenge for the global shipping industry, not because solutions don't exist, but because the scale and economics of modern shipping make perfect safety essentially unachievable. The industry moves an almost incomprehensible volume of goods across oceans every day, and even with improving technology and better regulations, a small percentage of that cargo will end up on the sea floor. The effort going forward is about continuing to reduce that percentage, understanding the environmental consequences more clearly, and building systems that make accountability and prevention more consistent across an industry that spans every ocean on the planet.